whole quadratic formula down here. I'm even going to include the x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, now the discriminant is just the part that is underneath the radical. So b squared minus 4ac is the discriminant. That right there is the discriminant. Okay, it allows us to find out what kind of answers we're going to have without going to all the trouble of working out the entire problem. All right, now we're going to have some scenarios here. All right, I can work this value out. I can plug in b, I can plug in a, c, work that out. I'm going to get a number. Okay, the number is either going to be positive, it's going to be 0, or it's going to be negative. So I've got 3 scenarios, all right, of what's going to happen. So let's try to line out those 3 scenarios. See how the best way to do this is. All right, so if my b squared minus 4ac is greater than 0, or in other words, if it is positive, okay? If it is positive, I am going to have 2 unequal real solutions. All right, we're assuming then A, B, C are rational numbers and the discriminant is a perfect square. Okay, so in this one, the discriminant is a perfect square. So let's just put discriminant perfect square. All right, so it works out nice. So it's square root of 36, square root of whatever underneath there. The solutions are then going to be also, I can add a little bit of thing. I can say they're going to be rational as well. All right. So if A, B, C are rational numbers and the discriminant is a perfect square. Okay, so actually I need to say that A, B, C, comma, 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 are rational. And the discriminant is a perfect square, then I know they're going to be rational. If the discriminant is not a perfect square, the solutions are going to be irrational conjugates. Now that's way more than what you did in high school. In high school, we just said, okay, if this is positive, you're going to get 2 unequal real solutions. All right, that was the main part that you were taught in high school. All right, however, now if we start analyzing what that discriminant is, when it's a perfect square and A, B, and C are rational, then I know that those 2 real solutions are rational numbers. If the discriminant is not a perfect square, then I know they're going to be irrational, and I can go even farther and say they're going to be irrational conjugates. Okay. All right. So there's one. Case number 1, scenario number 1. Okay. So case number 2, if b squared minus 4ac is equal to 0. All right. If it is exactly equal to 0, I have 1 real solution, and I'm going to say a repeated solution. And we'll kind of address that here in a minute. And again, if A, B, C are irrational if they are rational, the repeated solutions are also a rational number. Okay, so solutions are rational. So if A, B, C is rational, and my overall thing is going to be rational as well. All right, now this is the scenario where, let's draw a little picture with this. This is the scenario where the vertex might be sitting right there on that x-axis, and I've only got 1 solution. All right, it's going to be rational. And then if it was factorable, it might factor into like an x plus 4 and x plus 4, a perfect square trinomial that has its zeros right there on the x-axis. All right, so when it's repeated and you do quadratic formula, you're still going to get 2 numbers, but they're going to be the exact same number. Okay, so that's why I said repeated solutions there. All right, third case scenario, your b squared minus 4ac is going to be less than 0, or in other words, it's going to be negative. So when I get a negative, okay, well, that would be under the radical, right? A negative under the radical, which means I'm going to have those imaginary things. So I have no real solutions, but instead I have two imaginary solutions. And the solutions are what's called complex conjugates. And again, that's not something that would have been in high school. We would have focused in high school just, oh, you got one real solution, you got no real solutions. Probably would not even have said anything about them being imaginary. All right, but if you have them imaginary, the solutions are complex conjugates, okay? And then again, if we wanted to do a little rough sketch, this one would look like what? Doesn't touch the x-axis at all. So it could be an upright one above the x-axis. It could also be below the x-axis upside down. So in other words, that parabola is not going to be touching that x-axis at all. All right, so my guess is in the homework, you're going to have to answer questions just specifically about the discriminant. And in the past, this has been on the final exam, okay? So 2 points, 5 points, whatever. They will ask a section that you will have to have these three cases memorized. All right, now let's do some examples that involve these three. All right, you're not gonna have it memorized yet, so you'll have your notes, all right, that you can look at. All right, let's say that I'm gonna actually write out the directions on this one just so we know exactly what it's doing here. It says compute the discriminant. Okay, so obviously you would have to calculate that value before you could do anything. All right, then determine the number and type of solutions. All right, so we'll do at least a couple here. All right, let's suppose we had a 3x squared plus a 4x minus a 5 equals 0. All right, so I'm going to identify A, B, and C like we have been. There's A, there's B, there's C. All right, so the first thing I'm going to do is I'm going to calculate out that discriminant. So I'm only going to do the B squared minus 4AC. That's the discriminant, okay? So B squared, I am going to do a little bit of this math in my head. 4 squared is going to be 16 minus 4 times 3 times a negative 5. Thought it might be a good idea to write all that out. All right, 4 times 3 is 12 times 5 is going to be a 60. And I got a minus minus. So it'll be 16 plus 60, which gives me a 76. Okay. I got 76. It is a positive number. Okay. So when it was a positive number, this is case 1. I know I have 2 unequal real solutions. So I have 2 solutions. They're going to be rational because those are all rational numbers. Okay. Now, oh, wait a minute. Is it going to be rational? No, perfect square. All right. So in other words, can I do the square root of 76 in my head? That's not a perfect square. This is not a perfect square. All right. So because it's not a perfect square, they are not going to be rational. Okay. They're going to be irrational conjugates. Irrational conjugates. So overall answer, what am I going to have? I'm going to have 2 irrational conjugates. And let's be a little bit more specific because it is positive. I know they're also going to be real. So let's add that on there too. I'm going to have 2 real irrational conjugates. So how many? 2. What type? Real irrational conjugates. All right. That's the part. You got to have that chart memorized. Like, see, even I had to look back at that chart because it's been a while since I've done this. Okay. So there's no way you're going to get the type. All right. You might remember the how many from high school, but the knowing those types, you're gonna have to memorize that chart. All right, let's try another one. Let's do like a 9x squared minus a 6x plus a 1 equals 0. All right, so again, we've got our A, we've got our B, we've got our C. All right, so first step is always calculate that discriminant. So you've seen what you're looking at. So B squared minus 4AC. All right, again, let's do a little bit of this math in our head. B is -6. -6 squared is going to be a 36. Minus, I am going to write all these down. 4 times 9 times 1. That's 36. So 36 minus 36 gives me exactly a 0. Okay. So which scenario is this? This happens to be our second scenario. All right. When, right? Yes, when it equals 0. All right. So how many do I have? I'm going to have one real solution. And everything was rational. It's a repeated solution. I know it's going to be rational because ABC was rational. One real solution that is rational. All right, and you can write that a variety of ways. I could have wrote it one real rational solution. I could say one real solution that is rational. The fact that it's real and rational, that's the type. The fact that there is one is the number part of it. Okay, so like I said,